In this video, we are going to look at a quick review of percents. Now, when we talk about a percent, what do we mean? Well, if we take apart this word and we have per and cent, then we see that percent can be interpreted as per 100. A percent would give you how many out of 100 is represented. So let's take, for example, a student answered 24 out of 32 questions correctly on an exam. As long as each question was worth the same amount, we could calculate the student's grade by taking 24 dividing by 32, which as a decimal is 0.75. Now, if we wanted to turn this into a percent, then this would mean that we have 75 hundredths, or 75 out of 100, and that is 75%. So we're going to be looking here in just a little while of how we go from fraction to decimal to percent. But you can see that the first step to do is to calculate the part out of the whole, and then interpret that as how many out of 100 for the student to have answered correctly. So why are percents important? Well, they're important all over the place. So if you want to think about some of the places where you may have encountered a percent recently, it probably won't take you long to figure out how frequently you encounter percents in your everyday life. What's important is, in particular, when we're trying to do comparing. So if you're trying to compare two things, then it may be better to express as a percent. So I'm taking a look at the nutrition facts on a box of crackers that I have in front of me, and it'll have the total fat is 4 grams and the total carbohydrates is 20 grams. But how do I know if that is good or bad? Well, if you look at the percent daily value that's there listed on the back of the nutrition, or on the box on the nutrition facts, it'll give you a percent there of how that represents your percent daily value. So 4 grams of fat represents 5% of how many fat grams that you should have in a day, whereas those 20 grams represent 7% of what you should have in a day. So that's an example where if you were trying to compare how big of a slice this food is taking of your daily amounts that you should be getting for fats and carbs and all of the different types of macronutrients, then you can use the percents to help you make a comparison. You also would see percents when you were trying to look at maybe the pass rate of a course. You may have a class with 10 students or a class of 100 students, so I would not want to look at the total number of students who passed. I'm more interested in the percent who passed. If I told you 8 and 80 students passed, well, that doesn't mean anything without knowing the size of the class. If it was out of 10 or out of 100, here we see that the pass rate would be the same, 80%. So percents can be really helpful in comparing two values to help us get a better picture of how it represents the whole. Well, let's take a look at something that may happen in sports. Last minute of the Super Bowl, everything is at stake. The game is tied up. You have a chance for an extra point kick. The team needs to pick the kicker. Who do we go with? Well, Steve has made 14 out of 19 field goals. Jason has made 9 out of 12. So who should we pick? Well, why don't we calculate the percent that they get? Steve is 14 out of 19. If we calculate that, we do the division. 14 divided by 19 is 0.737, which is 73.7%, whereas Jason has made 9 out of 12, 0.75 or 75%. And that tells us that Jason is a slightly more accurate field goal kicker when we look at percents. Now, you may want to dig a little deeper and think about things like Steve has more experience or any of those other topics. But if you're just looking at who has the higher percentage, we would go with Jason. And this is a great example of how when you have a different number of things that have happened, that using percentages makes it a lot easier to do comparisons. Now let's do a little bit of the mathematics of how we were working between the different types of percent, decimal, and fraction. So if you have 90%, then that means you have 90 out of 100. And with decimals, 100th is in the second decimal place after the decimal. So 90% would be 0.90 to represent that you had 90 100ths. Really what we're doing is we're taking the decimal, and if you're moving it over twice, that can help you turn that into your decimal notation, so moving it to the left twice. To do as a fraction, the simplest thing to do is to take your percent over 100 and then reduce this. You can take the 90 and the 100 and divide both of those by 10. 90 divided by 10 is 9. 100 divided by 10 is 10. And 9 and 10, you can't simplify any further. They can't be divided by any of the shared numbers, so we're finished with that simplification. If you take a look at the next row, our decimal 0.091. Well, this is actually 91 thousandths because we're into that third decimal place. So when we want to turn this into a percent, we'll do the opposite direction and see that this is 9 hundredths and then that thousandths, making this 9.1%. So move that decimal over twice to the right to turn your decimal into a percent. Now here, if we want to get this into fractional notation, we can't have a decimal and a fraction, so this is where it would be useful to think about this 91 thousandths. That's representing 91 out of 1,000, and it turns out you cannot divide either of those numbers by the same thing, so this is actually simplified. Here we have on the next row 3 1/4. Now that 3 will stay as a 3, and it'll be 3 point, and then we have to take that 1/4 and turn it into a decimal. All you need to do here is 1 divided by 4 in your calculator, you get 0.25. And so this is the same thing as 3 and 25 hundredths, or 3.25. To turn that into a percent notation, we'll do the same thing as we did before. We'll move the decimal to the right twice, and we get 325%. Now you may be thinking, can you have over 100%? Yes, there are some times where you can. And because our number all the way to the right was 3 and a fraction, then that was an indication that we were actually going to have more than 100% there. If you look at the next row, 115%, move our decimal to the left, and we get 1.15. Again, it was over 100%, so it is going to be a number to the left of that decimal point, unlike the first two rows where there was a 0. What would that be as a percent? I'm sorry, as a fraction? Well, the notation for percent is per 100. So here you can do 115 per 100, or you could do 1 and 15 hundredths. Either way, you will have to reduce this a little bit because they are both divisible by 5, the 15 or the 115 and the 100. So here we have 1 and 3/20ths, or we can think of this as 23/20ths. Those are two equivalent fractions. When you are dealing with percents in general for this class, we will round to the nearest tenth. For decimals, we'll round to the nearest thousandth. And then for fractions, we'll typically simplify as best as we can. So in this question, where we have 23 out of 43 starting as our fraction, if we want to get the decimal and the percent, we need to do some division. So 23 divided by 43 gives us 0.53488. Now, since we are going to be rounding to the nearest thousandth, we only need to have 3 decimal places. So take a look at that third decimal place. Look to the right. Is it less than 5 or is it 5 or more? If it's less than 5, then you would keep the digit before it as is. If it's 5 or more, you're going to round up. So since we're looking here at 8, that means that we are going to need to round up that digit to the left, making this 0.535. And then we can take that decimal, turn it into a percent by moving the decimal 2 to the right, and we get 53.5. And so you can see actually that having your percent rounded to the nearest tenth and having your decimal to the nearest thousandth is actually dealing with the same amount of place value digits. In this class, we will experience a lot of word problems. And so when we have a word problem representing percents, it's helpful for us to understand some key words here. So the what in our word problem, this is your variable, or your x, or your unknown. Basically, these are your question words. The question is going to ask you about something, and that what is what it's asking about. Anytime you see the word is, it almost always is representing equal, and the word of is almost always telling you to multiply, or to use multiplication. Multiplication symbols, sometimes we see dots, sometimes we see a little x. A lot of times in higher mathematics we use the dot because the x can be confused with the variable x. Now, a tip for working with percents, it is always best to use the decimal form of the percent when working on computations. Let's do a few of these problems so that we can practice some of the word problem computations that we'll have to do. What is 60% of 22? Well, we are trying to figure out the what, that's our x. We're trying to figure out what it equals, and if we want 60% of 22, we will take the 60% as a decimal, translate of to multiplication, and multiply that by 22. Now, I put that in parentheses just so that it can be a little helpful to see that you have the two numbers, but either way, you don't have to do the parentheses, but I like to put them there when I'm multiplying. We'll take that 0.60 multiplied by 22, and our answer is 13.2. Take a look at number 2. We want what percent? So we want x percent of 20. So make that of, that multiply by 20 is 1.93. So if we want to solve this one, we want to make this a little algebra problem, so we can make this 20x equals 1.93. And to solve for x, we need to divide by that 20 on both sides. And that gives us that x equals 1.93 divided by 20. We get 0.0965. And here, remember, this was asking us for a percent, and this decimal is not the percent. You would need to turn this into your percent at the end. When you do a problem like this, you are ending up with the decimal form, and move your decimal over twice to get the percent. All right, we've got 2 more here. 7.2 is 18% of what number? Well, let's do some translation. 7.2 is, that equals 18%. We will need to write this as a decimal when we're doing the math. And it's of, so we'll multiply. What number? I don't know, so we'll leave it as an x. So this problem, 0.18x equals 7.2 is how you can write this as an algebra problem. And I just I changed the order around so the x is on the left. We could have done it with x on the right. But divide by 0.18 to solve this one. 7.2 divided by 0.18. And here we're getting that x is 40. And this time x was not representing a percent. So our answer will just stay as 40. All right, one more of these writing equations. What is, well, what? I don't know. So we'll leave it as an x, is 110%. Write that as a decimal, 1.10 of, we multiply, 250. So this one we just need to take 1.10, multiply by 250 to get our answer of 275. We have a few word problems here that I would like for you to practice. So taking those examples that we just did, now that they're in sentences, try to set up your expression and solve these. Now, I will go through them in just a minute, but I would like for you to pause the video here and work through these examples as best you can, and then you can turn the video back on to check your work. So in this first example, we are told that 27% of the 4,126 students at John Tyler work full-time. How many students work full-time? We can take that 27% and make that 0.27 and multiply that by 4126, and that's going to give us how many students work full-time. The reason that this equals our x, this is our question word, how many students. So that's how we know what we're setting this equal to. We're finding the number of students because that's what this question wanted to find. So to calculate this, 0.27 times 4,126, and we're looking at 1,114.02. Now, use a little bit of context here. Rounding was involved. We're dealing with whole numbers of students, so you would not have 0.02 of a student. So here it makes sense that you would not have a decimal. Sometimes decimals are okay, but this is not one of those times because we're talking about students. And so that 0.02, we would round, or we would keep it at 1,114 and not round up. In example 4, before giving a family a mortgage to buy a home, banks require that the total monthly payment be no more than 28% of their gross monthly income. Assuming that a $1,600 monthly payment is the most that a family can afford, what is their gross monthly income? So the what that we have in this problem is the gross monthly income. Questions like this can be a little bit harder to set up into a word problem, and so I find it helpful to summarize what's happening here. We know that the monthly payment is 28% of monthly income. So if we take that word problem and we simplify basic as we can get, we found that the monthly payment is going to be 28% of the monthly income. This is much easier to turn into a algebra expression. Here we know the monthly payment, so we can represent that monthly payment in our equation. 1,600 is, that's our equal, 28%, write that as a decimal, 0.28 of, we're going to multiply the monthly income, that's what we don't know, so we'll represent that with an x. So 1,600 equals 0.28x. To get x by itself, we will divide both sides by 0.28. 1,600 divided by 0.28. We would need a monthly income of 5714.2857. Now, how many decimals make sense for this problem? We're talking about money, so it would make sense to have 2 decimal places, not 3, and not 1. You would want to have 2 because we usually have 2 decimal places when we're talking about money. So 5,714.2, what do we do with that 8? Does it stay in 8 or will it go up in 9? Look at the right of 8. You have a 5. That means round up, so we will round this up to a 9. Their monthly income needs to be $5,714.29. Example 5. Some of you may remember Circuit City, but some of you may not. It went out of business quite a while ago. But they were offering 40% off of some of their items to try to clear out their stock. So if, my spouse had been wanting a Blu-ray disc player, again, remember, it's been a little while, priced at $350. What was the sales price of the Blu-ray player? What would the total bill be after the discount and a 6% sales tax? So we've got a lot of things going on here. If we wanted to try to summarize this, your sales price, or the sale price is going to be the original price minus that 40% of the original price. And then we will have to pay some sales tax here in a second, but let's just get the sales tax part, or the sales price. The original was $350. We know this. The sales price is what we don't know. So we'll let X equal our original price of $350 minus that 40% of the original. So we'll multiply by $350. Order of operations here, we need to multiply first. 0.40 times 350, that is 140. So the sales price is going to be $350 minus $140. The sale price is $210. Now we need to pay sales tax. So how does that work? It's the purchase price plus 6% of the price. So we'll do this one similarly. Our purchase price was $210, but we need to add 6% of the $210. So we're going to take the 0.06 and multiply by 210. Order of operations, do that first. The sales tax, and this is the price plus sales tax, what this equation represents. So 210 plus the $12.60 in sales tax gives us a total purchase of $222.60. Now, a little shortcut when you're doing sales tax, that's actually kind of nice to use. You can always take your price and multiply it by 1 point, whatever the sales tax is, which in this case is 6%, so you can do 1.06, and whatever your price is, multiply by 1.06, and it'll get you directly to that answer. So that's just a little shortcut because sales tax comes up all the time. Take the price, multiply by 1 point, your percent, and you'll get your total price. All right, last example here, the school bookstore marks up books 20 to 25%. That's about what they have to mark up to pay for rent and employee salaries, all of that. And so if you paid $75 for your book after the bookstore had marked up the price 25%, how much did the bookstore pay for the book? All right, so what do we not know? X is the original price. That's what we don't know. So sometimes it can be helpful to define that for our problem. Now, what's happening? We have the original price that the bookstore paid, plus, and let's go with 25% of the original, and that's going to equal what the customer pays. So now that we have this summarized, we can start to put in some things that we know and we don't know. We don't know the original price, so we'll have to leave that as X. 25%, 0.25 of, we're multiplying, but we're multiplying by something we don't know, so we'll leave that X. And then it will equal the customer price. We know that was 75. So what do we do with this? We have an X and a 0.25X. So we are going to add those together. We have basically 1x and 0.25x. We add those together, we get 1.25x. And now we have our equation that we can solve. Divide by 1.25. 75 divided by 1.25 equals $60. And so that's what the bookstore paid. There is one more problem in this section of the notes for this chapter, and we are actually going to do this one as the collaborative assignment, or it'll be part of the collaborative assignment for this first week. So if you want to take a look at this question and be prepared to share what you're thinking, we are going to talk about this one in our class meeting, or if you're not attending the class meeting, then this will be the collaborative assignment that you'll complete after our class meeting happens.